Once you've created your DEM subset, you can use Spatial Analyst to create a hillshade. A couple things. Before we do that, open the attribute table and again look at the value and the count. And even though we reprojected these data when we created a subset from user-defined units to linear meters, the value count, which is the elevation, has not changed. So in the original DEM, these values represented feet in elevation, and the values here also represent feet in elevation. So we can see the lowest elevation on our DEM section is 292 feet to the highest elevation at 3,400 feet. So I'm going to use Spatial Analyst, Surface Analysis, and choose Hillshade. My input surface is the DEM. The azimuth and the altitude are related to the shadowing effect, or the hillshade effect, and these are sun angles. I'm going to leave the Z factor as the default. My cell output size is set for me, and I'm going to locate this as a hillshade. You can see I've been doing several of these, and say OK. This takes a few minutes to create the hillshade effect. Once the hillshade's been created, it's added automatically to your view window, and you can see you have a nice rendering of relative relief. Now if I look at the hillshade values, if I look at the attribute table for the hillshade, the values no longer are related to feet in elevation. Okay, it's really important to know that these are just counts. So how many color values, and I'm using this 254 stretch shading, and this is what these are related to, as a shading or a shadow value. So any analysis I need to do, for instance, when we do the viewshed analysis, we need to go back to the DEM because that's where my elevation points are. I can zoom in to the area, and I can also zoom to the raster resolution, which they feel is kind of, if I zoom in too much more, I get pretty pixelated, and this gives me a nice view of the area. So